我是一个
As I know that we really know how to learn from each other. The life science is very deep and finite, for which human beings learn little. Because we know little. If you know, you say you know. If you don't know, you say you don't know. My speech is about genome project, and this textbook has been wrote by many years, and for this I will not elaborate on that. A good textbook should be a combination of today and yesterday. To better understand the genomics, so I divided my book into 9 chapters. I always make it bullet points, which makes the highlights and kind of offer an executive summary of the highlights. And I even make a catchphrase for the keywords. Somebody said that life at a certain time must obey strict physics laws. And I have further experience and understanding of that, especially for ultrasound technology. As you can see that if you want to do a good job, you have to sharpen the weapon. For life science, it has never been drifted apart from the physics. So the life science is just like the other science and trials, which are a hypothesis-driven research. Just for our HGP, without sequencing technology, without computer, we will not have HGP project. Plus, there is a big hypothesis that all the secret of life are hidden in ATCG, the sequencing of ATCG. This is what we call the first revolution. And when I wrote the book called Biology, for those years, I think the biggest milestone of life science was 1953, when DNA, a double helix structure, was discovered. We call it the first revolution of life science. Although we all know we don't want to use the word revolution for life science and biology. That being said, I think many of the friends think this is another contribution made by the British. This is a contribution from the physics. Without this young scholar changed the course of learning, without the blood and flesh work, there will be no physics progress and medical progress. We shall contribute our success to the development of physics. Without the discovery of the life science and biology, without those British American experts, without Chargaff laws, then the ratio of purine, without the finding of the optimal ratio of purine, we will not have such a big progress. So the first revolution of life science is the best cooperation between the life science and physics. So I think we could call it the first revolution. You can see that James Watson wrote a book entitled The Double Helix Solution. So many translations have been made. In China, there have been over 10 versions of translation. Life is really beautiful. Just by looking at the micro world, life is so pretty and beautiful, so it prompted me to make a catchphrase of how to summarize and concisely talk about the beauty of DNA, and for today I don't have many hours. I would just like to briefly talk about why DNA is so important. 2 sentences. Double helix. What is the attributes of life? Life is to replicate DNA. And also the sequencing, ordering. The order of sequencing is the carrier of the gene information, thereby changed our view of life. So it is a great discovery. It has best interpreted the 2 phenomena into realities of life, which is to replicate in the replication of DNA. And life is so vast and complicated. You can see the diversity of life is because of the different sequencing of DNA. From the molecular level, no matter how life is interpreted at different aspects, the information is storage in the sequence which is linear and one dimension. And for genomic study, we have a saying that life is made of information. Life is intelligent and smart. And this has further been the basis of why the genomics work together with the imaging technologies. That is why DNA solution has best interpreted the evolution. There has been a saying, nothing in biology makes sense except in the light of evolution. So the student of him has been our founder of China's genomic study group. So what are the key innovations? In 1953, the milestone study has revolutionized our study in life sciences, how to validate and how to stress on the importance of DNA groups. For so many years, people try to unravel the mysteries, and those studies have already revolutionized the predecessors of the experts in life science. So the International Conference on Genomics has been celebrating the double helix discovery, and the meeting has been hosted for many days in Hangzhou. There have been 3 fundamental reasons. First being James Watson spoke highly of China's genomics contribution, even when at that time we haven't even done much. To quote what he said, our center is of equal footing with other centers. And when we finally strive to make contribution, he said that China is now leading genomics nation. Now we're leading genomics nation. And we have to learn from the other experts. China has not stopped. Those are the 6 head of states of different countries celebrating the first draft of the Genomics Group project. To quote what the paper said, remarkable advances in genetic science and technology have been made in the 5 decades since the landmark discovery of the double helix structure of DNA in April 1953. This brought me to another book, which has been 80 years old, which is from the physicist Schrödinger. questions still not fully answered for a century. So this is a letter to Erwin Schrödinger. He said, I attribute my book to your book, and I got great inspiration from your books. For this, in our Singapore Conference Center, we celebrated the book of A Question Still Not Fully Answered for a Century by Mr. Schrödinger. It has been the 80th anniversary since its publication. And now, what is the second revolution of life sciences? I have told the middle school students that the HGP project has been the main contributor to Chinese study in life sciences. And in June 26, in 2000, 6 capitals of the major countries, China, US, and UK, have jointly celebrated the milestone in the 23rd anniversary of announcement of completion of the draft sequence of the human genome. It has been said that scientists from Japan and Germany, France, China, around the world have been involved. And head of the states, according to alphabetical order, have been making important speech. That was the April 14th. This was the announcement of the celebration of anniversary of the announcement of completion of the draft sequence. From academic speaking, it was to celebrate the publication, and following on that, a special edition have been made for the celebration. After this commemorating journals have been published, it has been said that the HGP project is the project with the largest size to decode life. And HGP has developed a new study subject, which is led by genome study. And it is also safe to say that it is the first real cross-the-board study for the genome study. And this is yet another revolution, followed by the discovery of the double helix structure. I will not dwell on this picture because our British counterparts were not pleased because so many people joined the Manhattan projects, but no credits have been given to our British counterparts. For these 3 pictures, they represent 3 major projects of the 20th century who has changed the trajectory of the human life, and there have been a lot of stories behind it. One thing is to echo with big is beautiful. And now we have already get a gist of why big is beautiful, and genomic study and life science can be a big project to be collaborated widely on. And what other things have been left? What other contributions have been made? In total, there are 3 of them. Number 1 is the new tool for life medicine, life science. For this, I will not talk about sequencing technology. Without sequencing technology, there is no HCP project, and there will be no further medicine advancement. Like RNA, protein groups, and also on-site and immediately remote portable devices. There will be no of them. $1, 1 genome. If you really try to learn from the Americans, 10 years ago, the Americans talked about $1 for one genome. But for now, we're still saying that $1 for $10 for one genome. And another contribution was that a new field of science has been developed. So what is genome? Meaning, the combination of all different genes. The precise sequence of the bases is the code which carries the genetic information. You can see sequencing devices and computers are the tools behind the second revolution. I would like to ask you a question here. How big is it for a genome of a virus? You can see that it is finite in terms of its physical attributes. There are two groups. One genome groups to study all the the phenotypes, and also another group to study the genetic information and hereditary information. And all of those groups, be it genotyping plus phenotyping, they all revolve around the physics. For example, for phenotypes, it means genome plus the environment. Everything is based on the classic medicine and physics. So how big is the genotype? A phenotype? It is infinite as well. So what we have to do now is to know the definition of gene. For this, we have to link genome to phenome at all different levels to conduct genome-wide association studies, which we call it GWAS and IWAS, the image genome-wide association studies. Let's take a look at the challenge of this era. Let's take a look at how important the collaboration is, and also let's really give our salute to all the experts and guests who are from abroad. We are clear that the challenges faced by the human society, and let's continue our track record of the collaboration for the past 30 years, and let's really be here in China, for China and for the world. Let's usher in a new milestone together. Thank you.